Right, let's see what we can do now with a method of sorts. I think with any graph, the first thing we want to know in our minds is, what is this graph going to look like? So we know that a parabola is a curve that goes like this or like this. So we want to know, I would say to start off with, does this graph smile or does it frown? So how do we work out that? We look at the number. Which number? The one in front of x squared. So the number in front of x squared is a positive what? Positive 1. So if that is positive, it's 1, a is positive. Don't forget, greater than 0 means positive. Sometimes we forget that. And therefore the graph smiles. So it looks like this. Right, so now at least we know that's going to go somewhere on here. Now when you were drawing a straight line, what was your next step? You knew whether the graph went to the right or to the left, and then you found the y-intercept. So we do exactly the same here. And how do you find the y-intercept of any graph? You let x equal 0. And if x equals 0, we get 0 there, minus 4. So C, the y-intercept, is negative 4, which you would then mark off on your y-axis. Right, then when you did a straight line, what was your next step? Once you've got the y-intercept, you find the x-intercept. How do you find the x-intercept of any graph? You let y equal 0. Right, now for this graph, let's write this rather than rub it out. For this graph, there's y, so we get 0 is equal to x squared minus 4. Or if we want it the other way around, because we normally have 0 on the right, then we have x squared minus 4 equals 0. And now we spent ages this year doing factorizing. So remember, with a quadratic equation which has an x squared, we have to have something multiplied by something else give us 0, because that way we will know one of the two factors is 0. So this is what kind of factorizing that you've done lots of? Difference between two squares. And so that will be x minus 1, x minus 2, x plus 2 is equal to 0. So something times something else gives you 0. One of these two equals 0. So therefore x minus 2 equals 0, or x plus 2 is equal to 0. And therefore x is equal to, over here, positive 2, or over here x is equal to negative 2. And we can put these on the x-axis. So we're going to label everything now. Let's just get, we've got where it cuts the y-axis, we've got where it cuts the x-axis, we know it goes in this direction. And then next year you're always going to have to find the turning point. But in grade 10, because b, the x term that you might get, is always 0, you're always going to have your x and your y intercepts the same distance from 0. And so the y-axis is going to be your axis of symmetry in grade 10. So we don't need to worry about the turning point, but so it will be your y-intercept, but we will always show both the coordinates of the turning point on the graph for clarity. Alright, let's draw the graph on the axes. Let's make it go like that. Trying to make it look symmetrical. And it cuts the x-axis at 2 and at negative 2. And always watch out, if they ask for coordinates, then you need to give it like that. Otherwise you can just put 2 and negative 2. Always give the turning points coordinates. So it's 0, negative 4. And I think you can see it's symmetrical about the y-axis. So we say the axis of symmetry is the y-axis. And you've done quite a bit on symmetry in transformation. So there we are, and that is x equals 0. The y-axis is x equals 0, just as the x-axis is y equals 0. Put arrows at the end of the graph, label the axes, and label the graph. So this is y is equal to x squared minus 4. So you will always need to have put both the x-intercepts and the y-intercept and give its coordinates and the axis of symmetry. And so that is y equals x squared moved down 4 units.